Hi students, this is AJ sir. Let's study 10th standard ICSE Math Chapter 2 Banking Recurring Deposits Exercise 2A and 2B.
We deposit money in our bank accounts to earn interest on them, to preserve the value of the money, to beat inflation. One way of doing that is through fixed deposits. Imagine you have 50,000 rupees lump sum. You put it in your bank account and book an FD, fixed deposit, for let's say 2 years, which has a fixed rate of interest. It is compounded, and after 2 years you get the amount, the maturity value, which will be the principal amount plus interest amount. But what if you don't have a lump sum amount and you wish to deposit 2,000 rupees every month for the next 3 years, let's say? You want to get into this savings habit where you invest 2,000 rupees per month, and after 3 years you will get a maturity value which is equal to the total principal plus the interest accrued over 3 years. But note that since you are investing or depositing 2,000 rupees per month, the formula for calculating interest will be different. Imagine you invest 2,000 rupees in April. That will be in your bank for 36 months, 3 years. Then in May, if you deposit 2,000 rupees more, that will be in the bank for 35 months, and so on. So after 36 such deposits, what will be the total principal amount that you would have deposited? It will be the principal amount per month, let's say 2,000 rupees, into number of months, which is 36 months. That's 72,000 rupees deposited. That's your total principal. So the total principal amount is P into N. Plus interest. That's the maturity value. That's what you'll get lump sum at the end of 3 years. But the formula for interest is P into N, N plus 1, upon 2 into 12, into R upon 100. P is the principal per month, N is the number of months, of course, and R is the rate of interest per annum. The derivation of the formula is not in your syllabus. You simply have to remember the formula and apply it to solve sums. Let's start with exercise 2A. Cancel questions 1 and 2, which are very easy and of the same type. The third sum. There are two people, A and B, both have an RD account. A deposits 1,200 per month. So that's the value of P. For 3 years, that's 36 months. On the other hand, B deposits rupees 1,500 per month for 2.5 years. So that will be 30 months. On maturity, who will get more amount and by how much? Rate of interest is same, 10% per annum. So first, let's solve A. It's good to write the data first and then write the formula every time. Substitute the values of P, N and R in this equation. Do the reduction, that is the cutting. Multiply. Remember, there is a plus sign out here, so you cannot cut any number here with a number out here. And after solving, we get a value of this and add them, we get rupees 49,860. Similarly, we will solve for B. You can do it below A as well. Write the data, substitute the values, calculate. And you shouldn't copy the answer from here. You work it out yourself. Practicing the multiplication and division is very important to avoid silly mistakes in exam. So the final maturity value is rupees 50,812 and 50 paise. So clearly B has the higher maturity value, and by how much? As they've asked, well, just subtract, find the difference, remember decimal below decimal point, and the answer is rupees 952.50. Next, the fifth sum. Mark it as IMP. A man has a recurring deposit account in a bank for 3.5 years. In this sum, the time period is given 3.5 years, so value of n will be 42 months. Rate of interest is given, and the maturity value is given. So we have to find P, that is the principal per month or the monthly installments. So we can use the same formula, substitute the values and get the value of P, but let me use another method for this sum. I'm going to use the method where I assume P to be rupees 100. This is the assumed principal, not the actual one. Principal per month. So now write the formula. Maturity value is this, substitute the values, and you get the assumed maturity value as rupees 5,103. What does it mean? It means if the principal per month was 100, then the maturity value after 3.5 years would be rupees 5,103 at 12% interest. These are assumed values. But the actual maturity value is given in the question. It's 10,206 rupees. So what's the actual principal then? Well, it's assumed to be x, cross multiplied. This is unitary method, and we get the value of the principal per month as rupees 200 per month. Next, cancel question 6.1 and question 7 because they are very easy. Just the values are different. Let's do the 8th sum. It's IMP. Mrs. Geeta deposited 350 per month for 1 year, 3 months. Maturity value is also given. In this sum, the rate is asked. So always they provide 3 values and the 4th value is asked. So we write all the data, then we copy the formula, we substitute all the values. You can see that only that R value is missing. So you solve further. I multiplied this and sent it to the left hand side. I subtracted. In the end, I got the value of R as 9% per annum. This is just straightforward algebra. Next, the 10th sum. That is also IMP. In this sum, the RD account has a per month installment of rupees 300 and the rate of interest is 12%. Maturity value is also given, and this time the time is required in years, that is n is to be found out. So after writing all the data, I use the formula and I substitute the values, but the challenge here is I see n at various places, n out here, here and here. That's the unknown variable. We have to solve this equation to get the value of n. First, get rid of the denominator by doing multiply the whole equation by 2. You can further divide the whole equation by 3 to simplify it. N and n terms together. Finally, we get a quadratic equation. And we have to do splitting the middle term, which is quite challenging for big numbers like this. We have to split 201 into 2 numbers so that their addition or subtraction gives me 201 and their multiplication gives me 5,400. So in the rough work, you have to check with various factors. I tried 1 into 5,400. The difference is way different from what is required. I want the difference to be 201. 2 into 3 into 4 into, it's just, the difference is too much. So let me just jump. Let's start with 20. 20 into 270 gives me 5,400. What's the difference? 250. And I want 201, so I'm pretty close. Next, 21, 22, 23, they are not factors. 24, yes. Then we divide 5,400 divided by 24 is 225. Okay, what's the difference? Jackpot. 201. So these are the two numbers. But be careful about the signs. 201 is positive, so it will be 225 minus 24. Check. 225 into negative 24 is negative 5,400. Yes, it works out. So now we know how to split the middle term. So don't give up, be careful and keep on trying. So after that, we have to remove n common from here and minus 24 common from here. Notice how this negative sign has become a positive sign because you took minus 24 out common. Clearly the brackets are same, so take out the brackets common and the remainder numbers out here n minus 24. So either this bracket is 0 or this bracket is 0 because their product is 0. That means n is either minus 225 or n is 24. But number of months cannot be negative number. So n is 24 months. But they want the answer in years, so our final answer is 2 years. This is the entire sum. Next, let's study the 11th sum. Mr. Gupta opened a recurring deposit account in a bank. He deposited rupees 2,500 per month. That's P. 2 years, so N is 24 months. Maturity value is also given. Number 1. What is the total interest earned? Well, interest formula, as we know, is P n plus 1 upon 2 into 12 into R upon 100. But in this sum, the rate of interest is not given. So let's not use that formula. Instead, we can simply use the maturity value formula. You see, maturity value is the total principal plus interest. Maturity value we know. Principal and number of months are also known. So we can find the interest, the total interest, which is rupees 7,500. And using this interest, we can find the rate of interest using this formula. Now let's start with exercise 2b. In exercise 2b, we'll cancel a lot of sums because they are of the same type as 2a, nothing new. So cancel 1, 2, 3. We'll solve 4 and 5 right now. The 5th one is IMP, just like the 10th one was. Cancel 6, 7, 8, 9 as well. Let's do the 4th sum. Mr. Bajaj needs rupees 30,000 after 2 years. So the maturity value should be rupees 30,000. 2 years, so that's 24 months. Rate of interest is given as 8% per annum. And they have asked the monthly deposit. That is, they have asked P. So it seems to be a straightforward sum. We had done such a sum earlier. But instead of assuming P as rupees 100, this time let me use a direct formula and solve. So I see that in the formula P is present at 2 places, here and here. That's fine because after substituting the values and cutting, we will get the equation 30,000 is equal to 26P, and we'll get the value of P as rupees 1153. That's 1153.846. But in the question, they mentioned find the amount in the multiple of rupees 5. Obviously, he can't deposit such a decimal value in the bank. So we'll round it off to the nearest multiple of 5, which is rupees 1,155. Only then will he be able to achieve the target of rupees 30,000. In fact, slightly more than that. If it was 1151.846, still we would have written the answer as 1155. Go for a higher value, not a lower value, because we have to achieve the target of 30,000 at least, and not lower than that. And finally, the 5th sum, which is an IMP sum. Mr. Richard has a recurring deposit in a post office for 3 years, that's 36 months. Rate of interest is given as 7.5% per annum. And now the interest amount is given 8,325. First, find the monthly installment. And then find the amount of maturity. First of all, since interest is given, we can use the interest formula, not the maturity value formula, but the interest formula. Substitute all the values and get the value of P, which comes out to be rupees 2,000 per month. And now, maturity value is P into N plus I. I is already given. P we found out and N was given. So we find the maturity value as rupees 80,325.
Hi students, if you found this video useful, press the like button. Also, to enroll for my online lectures or online test series, email me or message me on Instagram. Check the description for more information.